Okay, so as Bev said, I am Sian Taylor. I'm from Arrowtown in New Zealand, which is the South Island of New Zealand. And I became Passive House certified in 2012. I'm an architect by trade and continue to be. And a year after I got certified, we started Team Green Architects. That's my partner and I. And we design residential buildings in our region. And they are all using the Passive House process. So we use PHPP. Everything is highly insulated, almost always using triple glazed European joinery because our climate is very extreme here in Arrowtown. We have very cold winters with snow, sort of -9, and we have very hot, dry summers. Thermal bridge as free as much as possible, and air tightness, obviously, and balanced heat exchange ventilation in everything that we do. That said, not everything reaches certified Passive House, but this house, which I'm going to talk about, which is our house, was certified Passive House. So the story is this: our building code here in New Zealand is pretty woeful, and this is where we were living, and this is what we wanted. So we're in a typical New Zealand house, which this house was built in the 1980s, very thin, sort of 90mm walls, aluminium single glazed windows. And although this view is absolutely stunning in the summer, we've got Lake Wakatipu here and this mountain ranges all around. In the winter, for 2 or 3 months, this is what we were looking at, which is condensation, or that's if we were lucky, if we kept the curtains open, because it was so cold, often the curtains would close. And whilst we were living here, we were building homes which were warm, comfortable, healthy, low energy, and it reached the point that we had to do something ourselves, which is what led to this. So the first thing was, where do we build? And what we were looking for was land which was north facing. So this is the site that we bought. But we fell in love with this piece of land for a number of reasons. Obviously, the view is incredible. It's quite sheltered. As I said, it's north facing. But this farm here used to be Mark's granddad's old farm. So he has lots of fond memories of this area. So it was also somewhere which was really undervalued at the time. I couldn't understand why. We were building lots of houses in this region and looking over at this land thinking, why is no one living there? Now almost all the sections are developed, and it's completely different in terms of the value. But at the time, we just fell in love with it and thought as well that this big piece of land here was big enough for us to build quite a simple flat site house. But as with everything, when you're overtaken with the emotion of how great it is, we actually didn't realize just how much the site drops off here in terms of the area you can build on and goes back up the hill over here. So in fact, the incline of this site was incredibly steep to get a flat, a building that could have suited a flat site. But as with everything, the challenge meant that we've got a solution that actually benefits us in a lot of ways. So this is the final design, as in what we aim to achieve if we ever win the lottery. So what we've built right now is this bit here, and this essentially is a 2-bedroom. There's 2 bedrooms. We live down here. There's 2 bedrooms at the back and a bathroom, and then a living, kitchen room, dining room, and that is around 80 square meters. As I said, this is north facing, and I believe most of you are probably in the States, so you're probably wondering why the hell it's north facing. That's because that's where our sun is. And the roof slope also benefited us because then we can get solar panels on that roof. And the slope of the land meant that we could build this second story, which allowed us to build what originally was going to be a guest accommodation. My parents are originally from the UK, so it's kind of like a bedroom, bathroom, living space. But we basically moved in literally a couple of weeks before the first COVID lockdown. So this had to become immediately our office space. And within a very short space of time, I said to Mark, I didn't want to go back to our office in town. Not only is it wonderful living out here, but this house is just so comfortable, warm and pleasant that I knew this is where we wanted to be. So as a result of all that, we've completely gone to remote working. Mark and I work in what was supposed to be the bedroom. We have a sort of client meeting space in what was the living room, and this is our commute to work up here every day, which I realize we're very lucky to have. So the next challenge was the thermal envelope and achieving certified passive house. And I know from the work that we do that the two ways to make it cost effective is, number one, get your orientation right, maximize what's free, which is obviously the sun, which we already had in terms of our site, and then keep it really simple. So essentially the plan of this is a rectangle or almost a square, and it's just got one roof. So it's a really, really simple thermal envelope, which is critical to keeping the cost down. But it did come with its challenges. We've got this area at the back that we needed to retain. So we had to have a different type of construction for retaining at the back here. But essentially what we did, every single wall aside from this rear retaining wall is 165mm SIPS panel. But this retaining wall came with its own challenges because we have blockwork retaining concrete block here. We have 100mm of XPS on the outside, and we needed to line up the SIPS panel with this XPS. And obviously the structure needs to line up as well as the insulation, which it's not doing. So that was one of our first sort of thermal bridge detailing challenges. This detail here shows what we ended up doing. So this is the blockwork wall. This is the interstory detail. This is the 100mm of XPS. This is the SIPS panel. And all we've done is basically bolt a piece of 2x4 to the wall here, and that supports the interstory ply and then the SIPS panel on top. But what it meant is that the rafters, which are here, couldn't actually be supported on the structurally insulated panel, which they typically would have been, because the load line was not direct. So we had to put an additional 90mm frame, which is the only place we've had to do this, along the back wall to support these rafters. So everywhere else we've got the SIPS, and then we've got 45mm internal cavity fully filled with New Zealand wool insulation. The roof is a warm roof. Even though it's sloping, we've got a warm roof construction. So the air tightness actually is here, but we put an extra insulating batt underneath. And we ended up, it's not shown on this detail, but we actually ended up putting in tallow here as well, even though we've got our air tightness up here. We just wanted to achieve the highest level of air tightness that we could. And then our slab detail, again, was just trying to keep things simple. Typically in New Zealand, we insulate below the slab, and a lot of people have exposed concrete slabs. But to maintain a really simple thermal bridge free situation, we've got the SIPS, and then we've got the insulation above the slab, as is shown here. So this just shows this is on site. So that wall down here is where this is the piece of timber that was bolted to that wall. This is the SIPS panel. That is the piece of ply that's the interstory ply. And that is the tanked insulated blockwork wall below. So next challenge was windows. Windows are obviously expensive when you're doing a passive house. And if you look back, I'll just take you back to here. The original design just kept it really simple, glass all the way across. But when it came to it, that was going to cost too much money. So this big window here, which is the biggest slider that you can get, especially when you're transporting overseas, this whole window costs about $17,000. And every other window in our house, other than these two here, is very simple. We've got, I'll just try and show you. We've got square windows which just repeat themselves, these little squares. And they were about $900 each. And then we've got this massive, expensive window here. So to keep costs down, we basically changed the design and went for the biggest bit of fixed glass that we could get here. We've got an opening panel here. And it meant that we could have a change in the feel of the room, because this is the kitchen, the dining room here, and then we move into the living space here. So this is a lot more cozy. We've got a sofa behind here, and it just changes the feel within what is actually quite a small space. And then the cat flap. So this was an absolute nightmare, and it's embarrassing to say, but basically we didn't allow for a cat flap at first. Before we moved in, we weren't sure if we were going to get a cat or a dog, and then we got a cat. We moved in, and then, as I said before, it was lockdown, and we found two little kittens in our garden, which was our lockdown project. So we now have 3 cats, which was not the intention. So we had to put in a cat flap, and being architects, we're a little bit anal about things like lining up with cedar panels. Every single window lines up with the cedar, and each wall finishes on a complete cedar panel. So this had to line up. The cat flap in itself is expensive. It was a US one. I think it was, I don't know, $700 or $800. But it took a builder 2 days to cut this into the wall, form the flashings so that they perfectly suited this cedar cladding. And the cats can't use it because it's too heavy and too airtight. So after all of that, we've got this ridiculously ugly piece of timber with a bit of plastic holding the cat flap open and creating a hole in our airtight building to let the cats in and out, which seems absolutely ridiculous. So that's it. As I said, it's Certified Passive House, and we've been lucky enough to win a few awards, including most recently the winner of the Housing Award for New Zealand Institute of Architects, which is a great pleasure. And that is our passive house.